Okay, we're going to start at the top of the foldable. And what we're talking about today is imaginary and complex numbers. An imaginary number is the square root of a negative number. Imaginary numbers have the form bi, where b is a real number, and I equals the square root of -1. So before, when we would get things like the square root of -4, we would say that there was no real solution, which is true. But when we add in imaginary numbers, then we can have a solution where we will use I as the imaginary unit. It's the square root of -1. A complex number is complex. Go figure. It can be written in the form a plus bi, where both a and b are real numbers. Complex numbers include all the real and all the imaginary numbers. So actually, this whole time in math, you've been talking about complex numbers, but now we're going to explore a whole nother subset of complex numbers called imaginary numbers. Now, since the square root of -1 is equal to I, it's going to have some cool properties. So starting off, I said I is equal to square root of -1. So then, if I square I, that's like saying the square root of -1 times the square root of -1, which will simplify to just a -1. If I cube I, then it's like multiplying -1 times I again. So it's -1 times the square root of -1, or -I. Then if I do it to the fourth power, that's like saying square root of -1 times square root of -1 times square root of -1 times square root of -1. And if I take a pair of the square roots, that equals -1 times -1, and I get +1. And then what's going to happen if I do I to the fifth? I would multiply by I again, and I would end up, and this ends up being a cycle. So I just cycle through these four possibilities. And to kind of make those obvious, it's I, -1, -I, 1. Now you can always go back and kind of derive what these are, but I had a teacher once and she said it like this. She said, I won, like I won a game. I won, losers, i.e. negatives, go in the middle. So if you look, that's the same list I ended up with. So I won, losers in the middle. That's just a fun little mnemonic that you can use. So since this repeats 4 times, what you can do is divide your exponent of I by 4 and look at the remainder. So we're going to divide by 4 and look at the remainder. Look at the remainder, and I'm just going to abbreviate that. So in this first problem, I have I to the 9th power. So I'm going to do 9 divided by 4, which goes in twice, which leaves me with a remainder of 1. So if I look over here at my first part of my cycle, 1, then that tells me that I to the 9th will simplify to just a simple 1I. So that's going to give me I. But originally, I had a negative, so I need to bring that down. So my final answer is -I. And the next one, I have I to the 15th. So I need to divide 15 by 4. Goes in 3 times. which gives me a remainder of 3. The third thing in my cycle is negative I. That's right here. So I'm going to replace I to the 15 with negative I. In my problem, I already had a 2. So my final answer will be negative 2I. My last one, I'm not going to multiply by anything. I just have 30. So 30 divided by 4 gives me 7, 28, with a remainder of 2. So my answer is just going to be whatever I squared was, which is negative 1. Now, if you're asking a question, well, what happens if you have a remainder 0? Then that's a good question. You're just going to go with what I did the fourth was, which is just 1. So if you have a remainder of 0, whatever that base and power of I is just going to simplify to a 1. The next thing we need to do is learn how to simplify radicals when I have a negative underneath them. When I have a negative underneath, the first thing I want to do is take out that negative and write it as an I. So for instance, in my first problem, the square root of negative 12, I'm just going to write it as the square root of negative 12, the square root of 12I. I'm basically factoring out that square root of negative 1. And now I'm going to simplify my radical like you might have done before, where you do a factor tree. So I'm just going to choose 4 and 3, which gives me 2 and 2. And I'm looking for pairs of factors. So in this problem, I have a pair of 2's that can come outside the radical. Under the radical, I have to leave my 3. And at the end, I put I. 2 square root of 3I would be my final answer. In the next problem, I would rewrite it as negative square root of 32I. And now I need to do the square root of 32. How about 4 and 8? 4 breaks down to 2 and 2. 8 breaks down to 4 and 2, which breaks down to 2 and 2. That gives me 1 pair of 2's, 2 pair of 2's, and when I multiply that, I get 4. Left under my radical, I have another 2, and at the end, hanging out, I have an I. But wait, I forgot something, didn't I? This was a negative. So you can have a negative number as your answer with I. So if I had these two negatives going on, negative square root of negative 32, my answer is going to be negative, and I'm going to have an I in my answer. Let's try this last one. First, let's rewrite it. 3 square root of 100 I. Now, what is the square root of 100? Well, that's nice. It's a perfect square. So this is going to be 3 times 10 I. And what is 3 times 10? 30. So my answer is 30I. Next, we're going to add and subtract. When we add and subtract, it's really easy. We're basically going to treat the I like it was an X or a Y or some sort of other variable. And we're only going to combine it when it's going to be combined with a like term, when it also has an I. So if I'm adding, that's really like just distributing a positive 1. So I can drop my parentheses, which gives me 4 minus 8I minus 12 plus 23I, and now I combine like terms. So 4 minus 12 would give me negative 8. Negative 8I plus 23I would give me 15I. And I'm done. Going to do the same thing in the next problem. Just rewrite my problem because it's addition. Then I have negative 1 plus 9 would give me positive 8. Negative 7i plus 3i would be minus 4i. The next ones are subtraction. When I'm subtracting, I need to make sure I'm careful and I distribute my negative. So if I write my next line, I would have 6 plus 16i minus 18 plus 9i. Make sure those signs are correct. You need to change both the signs. Now I combine like terms. 6 minus 18 is negative 12. 16i plus 9i would be 25i. Last problem here. Distribute your negative. So my next line would be 1 minus 3i minus 6 minus I. Combine like terms. 1 minus 6 would be negative 5. Negative 3i minus I would be negative 4i. So adding and subtracting is pretty straightforward. You just need to make sure that if it's subtraction, you distribute your negative. Now, multiplying is just like you've done with multiplying with x's before, but we're going to have to remember that sometimes we're going to end up with something special because I squared is equal to negative 1. If I is equal to the square root of negative 1, squaring it will get rid of the square root and I'll end up with negative 1. So let's see how this is going to simplify. So in my first problem, I'm going to distribute 4i times 5 would give me 20i. 4i times 2i, think of it like x's. You would have plus 8i squared. But I squared is really special. I squared is equal to negative 1. So where I see an I squared, I'm going to substitute a negative 1, which would give me 20i plus 8 times negative 1, or for a final answer, 20i minus 8. Now, if you want to put it in the standard form, negative 8 plus 20i, that's fine, but I'm not super concerned about that right now. Now, you might have learned to do FOIL, or you might have learned to do the box. I'm going to use the box just because when we start polynomials, I'm always going to use the box. So if you haven't seen it before, what you do with the box is if I have 2 terms by 2 terms, I draw a 2 by 2 box, and I do 7, positive I, 4, and then the negative I, and I multiply to get inside the box. So that would give me 28, 4i, negative 7i, and negative I squared. Now what's kind of cool about doing the box with complex numbers is both your diagonals end up having like terms. So negative 7i plus 4i would give me a negative 3i. And what did we just say I squared is? We said I squared is negative 1. So this bottom box is negative 1, or the opposite of negative 1, which is a positive 1. So 28 plus 1 would give me 29. Now, if I wrote that out in more steps, you can do that. I could do 28 plus 4i minus 7i minus I squared, so negative 3i plus 28 minus I squared, and then I could be like, oh, I squared, you're negative 1, and change that, and I'd still get the same answer. But once you do a few of these, you'll start to see that pattern really quickly of it basically just changing the sign of whatever's in that box. Last, when I'm squaring a binomial, I have to remember that's like saying, in this case, 3 plus 2i times 3 plus 2i. That is the one thing you'll learn in my class if you leave with nothing else. When you square a binomial, it's like both sides of your box being the same thing. So this is going to give me 9, 6i, that's a horrible 2, 6i, and 4i squared. So 6i plus 6i is going to give me 12i. And then I have, I'll just do it in a couple steps, 9 plus 4i squared. But wait, what is I squared? I squared is -1. So that means I'm going to simplify that to 12i plus 9 minus 4, or 12i plus 5. Or 5 plus 12i, either one. And that's it. Come to class ready to go.